is the opportunity that dreamers and achievers are waiting for. The direction you follow is the direction you make for yourself. We give out these experiences and possibilities. What you analyze right here will stay with you always. To find your opportunity, kickstart with Immaculate College for Women. The college serves as a springboard for students. Students from our college achieved university rankings including Lavanya R. first rank with a gold medal from the Department of Commerce, Keetna P. ranked 7th in the Department of Physics, Jennifer A. earned a 10th place from the Department of Commerce. The college offers discipline areas. UG courses with a wide range of subjects. Bachelor of Science BSc in Computer Science, Mathematics, Chemistry, Botany and Physics. Bachelor of Computer Applications BCA. Bachelor of Commerce BCom in General, Computer Application, Corporate Secretaryship. Bachelor of Arts BA in Tamil and English. Master degree programs with MSc Data Science, MSc Chemistry, MSc Mathematics, MA English and MCom. Numerous crash courses are designed to promote the talents and creativity of students like Artificial Intelligence, Internet of Things IoT, Multimedia, Web Designing, Tally with GST, Robotics, Choreography. The upcoming short courses: Drone Technology, Aeronautical Engineering, Typewriting and Shorthand, Arts and Crafts, Tailoring, Beautician, Fashion Designing, Baking and Confectionery, Tourism and Hospitality, Jewelry Making and Driving. Parchment courses are offered in collaboration with Longford International College, including Aviation, Leadership, and Psychology to add extra credentials. Enroll in ICW to set yourself up for success. Applications are open for the year 2022 to 2023. Time is running out to apply for our college campus. Hurry up and get in. To know more about our college in detail, check out our college official website. Become an ICW student for a bright future. A new opportunity awaits. Let's get this started. Immaculate College for Women. Learn, light and liberate.
Good afternoon, everyone. A warm welcome to one and all present here today for the International Conference of Chemistry Department. And it's my great pleasure to be a moderator for conference. Chemistry is the mystery of chemical. Chemists are the detectives who solve the mystery. One important key to success is self-confidence. An important key to access self-confidence is presentation. Now this is the right time to see our presentation. Now I request Mrs. J. Leslie Josephine, Head of Department of Chemistry, to present her presentation about sensor properties of heterocyclic compound with nanoparticles molecular doctrine studies.
I am very glad to welcome you all. I am Mrs. Lisa Josephine, Assistant Professor, Immaculate College for Women, Cuddalore. My topic is sensor properties of heterocyclic compound with nanoparticles, molecular docking studies. Introduction. Nanomaterials have enabled advances in sensor design, such as miniaturizations, probability, and rapid signal response times. High surface area to volume ratios and facile surface functionalizations make nanomaterials highly sensitive to changes in surface chemistry, thus enabling nanosensors to achieve extremely low detection limit. Nanosensors are any sensor used to convey information about nanoparticles to the microscopic world. Their use mainly includes clinical medicine or as tools for other nanoproducts such as semiconductor, chip, or nanoscale machines. There are three kinds of materials are used to construct multicolor emission. They are organic dye dot, semiconducting polymer nanoparticles, quantum dots of different size, and lanthanide dot nanomaterials. Tunable multicolor emission natural materials have arriving significant notice for their optoelectronics, prospective light emitting displays, and biological characterization. Applications of nanosensors in medicine, national security, aerospace, integrated circuits, communication, transportation. Nanoparticles are sensors, any biological, chemical, or surgical point to detect information about nanoparticle on microscopic level. Why use nanotechnology for sensing? Smaller size, reduce power consumption, increase sensitivity, direct detection. Analytical techniques used for the characterization of synthesized compounds. X-ray diffraction, SEM, ADX, molecular docking studies. The schematic representation gives the photoelectron transfer of nanoparticle, adding a mixture of 4-methyl, 1-naphthaldehyde phenanthrene, 9,10 diode, and 4-methoxyaniline in the presence of ammonium acetate with boron trifluoride ethyl ethyrate. The reaction mixture was stirred at 80 degrees centigrade for 2 hours. The reaction was monitored by TLC. The product was filtered and then tried. Here, X-ray diffraction analysis is a technique used in material science to determine the crystallographic structure of material. Here, copper doped zinc oxide nanoparticle obtained by sol-gel method. The diffraction pattern met with JCPDS code number 18927102. The obtained crystal structure is primitive hexagonal. In the case of doping with copper, as the radii of zinc 2 plus ion and copper 2 plus ion are similar. Copper 2 plus can change zinc 2 plus in a pattern. The figure shows it is used to perform analysis on a wide range of materials at high magnifications and to produce high resolution images. Here, energy dispersive X-ray analysis is also used to provide elemental identifications and quantitative information. From the EDX spectrum, the presence of zinc, oxygen, copper, the signals confirms the purity of synthesized copper doped zinc nanoparticle. Then, the absorptions of emission spectrum of MMPI. It indicates the nanocrystals do not adjust to the excitations of the ligand. At 257 nanometer is due to the absorptions of the MMPI. The effect of increasing concentrations of nanoparticle on the emission spectra, the apparent associations constants have been calculated using fluorescence quenching equations. The good linear relationship between 1 by f naught f, that is, and the reciprocal concentrations of nanoparticle. The relative homo-LUMO energy level of an isolated MMPI molecule along with the conduction band and valence band edges of copper dope zinc oxide nanoparticles. Its expands quenching process is conformed to binding of MMPI with copper dope zinc oxide. The docking is used to predict binding interaction between the biological molecule with newly synthesized compound. As more negative binding energy indicates strong interactions between the ligand and target protein. The PDIDB in 1BNA. The table indicates parameters obtained by the interactions of MMPI with the copper dope zinc oxide nanoparticle. Conclusion: copper dope zinc oxide nanoparticle prepared by Sol-Gel method and characterized by XRD, some ADS, UV visible spectroscopy, and fluorescence spectra. The quenching process of MMPI is observed on the surface of nanoparticles. The MMPI to prefer bind on the minor grid of A to T rich region of DNA molecule. Thank you.
Thank you, ma'am, for your fabulous presentation. I call upon Mrs. S. Uma Mageshwari, Assistant Professor, Department of Chemistry, to present a topic on structural, electronic, and docking studies of novel sedative drug molecules.
Good afternoon to all. I'm Uma Mageshwari from Chemistry Department. My title is Structural, Electronic and Docking Studies of Novel Sedative Drug Molecule. There is enormous drug molecules. But I had chosen a clonazepam as for my presentation. Introduction. The clonazepam is a benzodiazepine derivative drug with highly muscle relaxant depression, neurologic disorders, including panic disease. Chemical, chemical formula of clonazepam is C15 chain Cl N3O3. The clonazepam acts on nerve cell to help calm abnormal electrical activity within the brain, and it may used for the treatment of anxiety. Dependence occurs in one-third of people who took clonazepam for longer than 4 weeks. If used during pregnancy, it may cause harm to the baby. It binds to a GABA receptor and increases the effect of neurotrans. Clonazepam was initially patented in 1964 and went on sale in the United States in 1975. It is available as generic medication. Less side effects. It causes blood vision, confusion, lack of motivation, short-term memory loss, and amnesia, especially with high doses. Occasional side effects. Occasional disorder effect of clonazepam include personality changes, increased frequency of sneeze. The Gaussian 09 program package was used the triple split valency basic sets of DFT, B3LYP, LAML, 2D, 2DZ method. Candidate molecule are calculated as optimized structure, geometry, molecular geometry, vibrational analysis, molecular spectroscopic, and HOMO and LUMO analysis, and molecular docking. Molecular geometry of clonazepam. From this table, the theoretical value is found that most of the optimized bond length are slightly larger than the experimental value due to the experimental calculation belongs to the isolated molecule in gas phase, whereas experimentally result belongs to the molecule in solid phase. Vibration analysis of chronosebum. The molecule shows the number of in-plane bending 61 and the molecule shows the number of out-plane bending is 29. Vibrational assessment for chronosebum. There is various stitching of molecule discussed in this table. C-bond stitching. The aromatic structure shows the presence of CH stitching vibration in the region 3100 to 3000 centimeter inverse. C-bond C-bond O stitching. The C-bond O stitching vibration is absorbed in the region 1850 to 1550 centimeter inverse due to the tautomerism substituted with hydroxy group are generally in the keto form and therefore have a strong bond due to the carbonyl group. So C-bond O stitching is obtained absorbed in 1672 centimeter inverse. CCL stitching. The CCL stitching vibration gives generally strong benefits in the region 565 to 150 centimeter inverse. So CCL stitching is absorbed in 126.61 centimeter inverse. NH stitching. NH stitching usually occur in the region of 1500 to 1400 centimeter inverse. Molecular electrostatic potential for chronosebum. The molecular electrostatic potential surface analysis donates the understanding of relative polarity of the molecule. The negative electrostatic potential are represented in red color. The positive electrostatic potentials are blue color and green donates the surface or where the potential are close to zero. From the candidate molecule, the negative region located in the amino group and carbonyl group, the positive region locate all over the molecule. To predicate the reactive sites for the electrophilic and nucleophilic activity, B3LYP and LAN-L2D-Z optimized geometry, the negative region is related to nucleophilic reactivity. The B value are obtained on the molecule surface defined by the electron density 9.184 eV. In the figure, negative potential value is from 9.184 eV and in effect it is found above and below the phenol ring might seem to be due to the pie chart. Hence it is expected site from the electrophilic attack. Homo-LUMO analysis of chronosebum. Highest occupied molecular orbit and lowest unoccupied molecule, energy gap between the HOMO and LUMO is very low. So the compound will be more active. This table indicates the global parameters such as global hardness, softness of a chronosebum, the 0.095 and 0.5153 respectively. The softness of the molecule is positively qualitative. Docking. Identification of a ligand correctly binded geometry in the bind site. Auto-docking is a molecule method stimulate software. It is especially effective for proton-ligand docking. Auto-docking is one of the most cited docking software in the research community. Proton the data bank and proton 1 TRI ligand chronosebum. Hydrogen bond diagram of target molecule with chronosebum molecule. The predicate how the protein molecule interact with the ligand. The protein was obtained by PBID1 TRI with tuberculosis protein. This table indicates the energy gap. Binding energy of synthesis compound is minus 6.4. Hence, the synthesis compound have better docking score. Conclusion. The electronic study of candidate molecule by density function level of theory given insight to the molecule geometry parameter, homo-lumo energy value, hyperconjugation interaction, and chemical reactivity, used to investigate the drug-protein interaction by docking method. Molecule docking used to bind the protein and ligand. These are the some reference I had used to prepare the presentation. Thank you one and all.
Thank you, ma'am, for your amazing presentation. I would like to call upon Sister Dionida, nurse at Assisi Hospital, Erayu, Kallakurichi district, to give her presentation about biochemical and oncomolecular genetic analysis of cervical cancer patients in Salem.
Past accessing. உங்க போட்டோல காமிச்சு அந்த மெயில் ஐடிக்கு தான் லிஸ்ட் பண்றது சேர்ந்து எடுக்க முடியுமா அவங்களோட எப்படி
Hello,
Mm,
sister, you can start now.
okay. Good afternoon to everyone. My title is Advances in Medical Sciences. Role of the early short course corticosteroid treatment in ARDS caused by COVID-19. A single center retrospective analysis. The abstract. Purpose. Severe coronavirus disease 2019, COVID-19 is strongly related to interstitial pneumonia with frequent development of acute respiratory distress syndrome. The role of corticosteroids treatment in these patients is still controversial. Some studies evidence a possible role of an early short-term course of CS treatment in the treatment of severe pneumonia. Patients and methods. This is a single center retrospective study considering the patients with confirmed COVID-19 pneumonia admitted to a hospital between 9 March and 15 June 2020. Two groups were considered: early high dose of methylprednisolone and the control group. Patients in the HDM group received the dose of 5 to 8 milligram per kilo and per day of methylprednisolone for 2 consecutive days. Primary outcome was the mortality evaluation. Secondary outcomes were clinical improvement, side effects, and laboratory radiographic changes. The results. Significant differences between the two groups were length of hospitalization. They are different between 21.5 to 28.4 days. Length of non-invasive ventilation or mechanical ventilation 11.5 to 14.5. The death ratio is 5 to 12 and clinical improvement is 16 to 12. The following factors were related to in-hospital mortality in the multivariate analysis: comorbidities and also the days from the onset of symptoms and the hospital admission, and the ratio, the oxygen levels, it's deeper than 95%, and the treatment, the HDM given 95%. The conclusion, the HDMS is interesting and promising approach in the ARDS related to COVID-19 pneumonia, which reduces mortality, length of hospitalization, and the used for mechanical ventilation. Introduction. The outbreak of novel coronavirus disease 2019, COVID-19 is currently a global health emergency. Due to respiratory illness caused by this infection with progression to critical hypoxemia and the development of acute respiratory distress syndrome. The ARDS related to the severe acute respiratory syndrome coronavirus 2, that is SARS-CoV-2. Infection is associated with a high mortality rate. In patients with evidence of SARS-CoV-2 pneumonia, the effectiveness of supportive treatment with oxygen, ventilatory support, or low molecular weight heparin was reported. Among the adjunctive immunomodulatory agents, corticosteroids have been widely employed in ARDS and in other viral infections. Recent studies evidence the improvement in different clinical outcomes with a high dose, short-term and early administration of methylprednisolone in patients with initial ARDS. In this retrospective study, we analyzed the real-life benefit of early short course of CS treatment in patients with critical COVID-19 infection and ARDS. The methods. The first one, study design and definitions. We define the following clinical categories: mild disease, defined as the presence of symptoms with pulmonary infiltrate but without hypoxia. Moderate disease, defined as pulmonary involvement with the need of supplement oxygen. Severe disease, defined as the presence of moderate or severe ARDS according to the Berlin definition with a need for non-invasive ventilation or mechanical ventilation. The second one is study endpoints. The primary endpoint was the comparison of mortality between patients receiving HDM treatment as well as RT or other CS or without CS, that is for the control group. The secondary endpoints were the evaluation of clinical improvement between the two groups of patients, defined as escalation to an ICU from non-ICU hospitalization, and the side effect or other clinical complications that occur during the observation period. Changes in WC, platelets, CRP, ferritin, D-dimer, procalcitonin, and also the arterial ratio in oxygen, the fraction level in oxygen ratio, and radiological improvement were also assessed and compared among patients receiving HDM treatment compared to the control group. The third one, statistical analysis. In descriptive statistics, continuous variables were summarized as median, that is 25th to 75th percentage. The categorical variables were described as frequency and percentage. And also the fourth one is the ethical issues. That is, the study protocol was approved by the local ethical committee. This study, which involves human participants, is in compliance with the 1964 Helsinki Declaration and its later amendments. The results. Patient selection and baseline characteristics. The flow chart is there, the next line, that explains very well about this. We evaluated 289 patients with a suspected diagnosis of COVID-19 infection. We excluded 46 patients, that is 22 without pulmonary involvement, 6 with a negative PCR or a nasopharyngeal test, and 18 patients who died within 24 hours of hospital admission. Among the 243 patients with confirmed COVID-19 related pneumonia, 18 had a mild disease, 142 had a moderate disease, and 83 had a severe disease with confirmed diagnosis of ARDS. In this group, 31 patients received the HDM treatment, while 52 were considered as the control group, in which 10 did not receive any CS treatment. 34 were treated with other CS like dexamethasone 100 to 20 mg per day, methylprednisolone 20 to 40 mg per day, hydrocortisone 100 to 500 mg per day, and 8 received the late HDM. The characteristics. According to the age, the total number it is 83. The HDM group, they are 31. The control group is they are 52. The ratio is shown here according to the age, the sex, and how much disease they have, each one, the hypertension, diabetes mellitus, cardiovascular disease, immunologic disease, neoplastic illness, kidney diseases, chronic obstructive pulmonary diseases, directly admission in ICU, the days from the onset of symptoms, the days of CS start after the disease. It is shown in the ratios we can see in the board. Those who have received ARDS, the mild and moderate and severe. Those who require the ventilation and those who require the vasopressor support and those who with a baseline score, the median, and also the baseline score with the PRCSS and SOFA baseline score, and the laboratory items. They are WBC, platelets, CRP, creatinine, D-dimer, procalcitonin, and oxygen levels, and the lactates mother and the PEEP, how much they have received and how many ratio is given below. The clinical outcomes, the days of hospitalization, the median they are 26.5. The days in NIV they are 11.8. Days in mechanical ventilation they are in 10.5. Death is 17%. Clinical improvement 27%. Sepsis they are 39%. Canteen BRs 14%. Documented 16%. The laboratory and radiological changes at 48 hours after receiving the treatment. The increase of arterial and fraction level, it is 10.5%. The CRP reduction is 5.5%. The creatinine reduction is 122.5%. The radiological improvement, they are 32%. Here it is, the days from the onset of symptoms and hospital admission. Those who admitted, those who admitted in the ICU here given, and also they are non-ICU admitted. The chart shows properly. And also the reduction of CRP, C-reactive protein. Beginning, they are none of them. After taking methylprednisolone, some of the people, and after taking dexamethasone, they are 9%. Then when they are taking highly dose of methylprednisolone, they are more than 15%. People have reduced the CRP. And also in the oxygen level, the arterial level and the fraction, when they are after 48 hours, the control group is in the 35%, and when they are taking nearly high dose of methylprednisolone treatment, they are this much level. And treatment received in the study population. We have given the antimicrobial treatment, that is ceftriaxone alone, 11%, and ceftriaxone plus azithromycin 6%, and piperacillin 15%, and ceftazidime 11%, and Pactum and Ceftazidime 10%, Levofloxacin 4%, Cefixime 9%, Fluconazole 2%, and the antiviral treatment, hydroxychloroquine 41%, Lopinavir 17%, Darvinavir 13%. Without antiviral treatment, they are 12%. Discussion. The beneficial effect of this approach was also confirmed by the improvement in inflammatory, biochemical and radiographic parameters in the HDM group. Among the factors significantly associated with higher mortality rate in our study population, we highlight the time from the onset of symptoms to the hospital admission. For this reason, clinicians should play an active role in promoting the correct information about the COVID-19 risk in the outpatients regarding the need of home treatment and monitoring and early hospital admission before the worsening of clinical condition and ARDS onset. In fact, a median difference of 6 days late was strongly related to the direct ICU admission of patients with consequent higher mortality rate. The relationship between the early use of CS in COVID-19 pneumonia and lower mortality was recently reported in the study by Monidora et al. Patients who have never received CS during the hospital admission had higher mortality rate than patients with early CS treatment. In this setting, patients with high inflammatory markers requiring ventilatory support may benefit from the CS treatment. Beneficial effect of the standard dose of dexamethasone may conversely be an alternative for patients with mild COVID-19 pneumonia with the need for oxygen support but without ARDS, as reported in the recovery study. In our present study, the most important factor associated with higher mortality was the presence of one or more comorbidities, the presence of chronic heart failure, diabetes mellitus, COPD, and other illnesses leads to the unfavorable outcome in patients with COVID-19 pneumonia. The clinicians should focus their attention on the modifiable factors such as timing of admission, timing of therapy, and early CS administration. Moreover, the lower rate of EAP in the HDM group can be related to the shorter hospitalization time and lower rate of mechanical ventilation in this group. Limitations of the study. The conclusions of the study are not definitive, and several limitations are related to the retrospective design. Limited sample size of the two groups, the heterogeneity of the control group without randomization. In addition, the standard definition of early and late ERDS were derived from the Berlin criteria. Although the COVID-19 related ARDS presents some different characteristics which could make inapplicable the same parameters used in the standard definition of ARDS. Conclusion. In conclusion, we focus the attention on the role of early CS administration in COVID-19 ARDS, with encouraging results in mortality reduction and shortening of hospitalization time using the HDM approach. Further, randomized studies are urgently needed to confirm these promising results in patients with COVID-19 related ARDS. Thank you.
Thank you, sister, for your wonderful presentation. Now I request Dr. S. Chandrakumari, Assistant Professor, Department of Chemistry, to give her presentation on design spectral and biological evaluation of benzohydrazide derivatives.
A very good afternoon to one and all. I'm going to share a few things about design, spectral, and biological evolution of benzohydrazide derivatives. My objective is to synthesize the benzohydroxy compounds using titanium oxide catalyst, and also to know the catalytic activity of titanium oxide rutile semiconductor, and to study the antimicrobial and homolumomolecular orbitals of benzohydrazide derivatives. A benzohydrazide compound contains a carbonyl group, CN group, and NN double bond group. Because of the presence of these group, the molecule exhibits a variety of hormological activities, and also it behaves as an ambident nucleophiles in several reactions. The synthesis of benzohydrazide derivatives involves four steps. In first step, a titanium dioxide catalyst is synthesized by Solger method, and in second step, a substituted sulfonamide is synthesized. In step 3, the synthesized product is reacted with the hydrogen hydride and to form a hydrogen substituted product. And in the fourth step, the synthesized compound 2, 3, and 4 is formed. First, let us see the synthesis of titanium dioxide nanocrystal by Solger method. 1 ml of titanium isopropoxide is dissolved in 20 ml of isopropyl alcohol. And then the solution is transferred to a beaker containing 10 ml of distilled water. The pH is maintained between 2 to 6 by the addition of 1 molar nitric acid and 1 molar sodium hydroxide. After maintaining the pH, a white salt gel is formed, and then the solution is allowed to vigorous stirring for overnight to settle the product. After that, the solution is centrifuged to separate the product solid particles and a liquid substance, and then it is allowed to dry. After that, it is calcinated at 300 degrees Celsius for 4 hours. Then we get a fine crystals of titanium dioxide product. This is a synthesis of a compound. This is scheme for the synthesis of compounds 1 to 4. First, ethyl amino benzoate is reacted with the sulfonyl chloride in ethanol medium with the presence of a small amount of titanium dioxide, and this mixture is stirring for 1 to 2 hours. After that, the product sulfonyl amide is formed. Then it is refluxed with hydrogen hydride in ethanol medium for 10 hours. The substituted carbonyl phenyl hydrazine compound is formed. Then the compound 1 is reacted with 3 different types of substituted benzaldehyde for 3 to 4 hours in acetic acid medium. The synthesized compounds 2 to 4 is formed. IR spectrum of compound 1. The stretching frequency obtained at 3319 cm inverse confirm the presence of NH group, and the aromatic stretching frequency obtained from 3046 to 3150 centimeter inverse. The aliphatic stretching frequency ranges from 2876 to 2940 centimeter inverse. The carbonyl group present at 1649 centimeter inverse. Let us see the IR spectrum of compound 2. Here, the NH stretching molecule obtained at 3224 centimeter inverse. The aromatic stretching frequency obtained from 3047 to 3079 centimeter inverse, and the aliphatic stretching frequency obtained at 2875 to 2938 centimeter inverse. The carbonyl group obtained at 1641 centimeter inverse. The C double bond N obtained at 1606 centimeter inverse. This is a proton NMR spectrum of compounds 1 to 4. For compound 1, the CONH proton obtained as a singlet at 10.61 ppm, and the SO2NH proton obtained as a singlet at 9.75 ppm. The methyl proton obtained at 2.29 ppm, and the aryl protons are ranges from 7.10 to 7.86 ppm. With the compound 4, the CONH obtained at 11.70 ppm, and the SO2NH proton obtained at 10.60 ppm. The C double bond NH proton obtained at 8.25 ppm. The methyl proton obtained at 2.27 ppm. Aryl protons ranges from 6.95 to 7.74 ppm, and the methoxy proton obtained at 3.74 ppm. This table shows the carbon NMR spectrum of compounds 1 to 4. Here, the methyl carbon obtained at 20.77 ppm, the carbonyl carbon obtained at 165.86 ppm. Aromatic carbons are ranges from 118 to 144.08 ppm. And in the compound 4, the methoxy carbon obtained at 55.33 ppm. This figure shows the XRD pattern and some images of the synthesized titanium oxide nanocrystals. Here the XRD pattern is matches with the JCPDS pattern of tetragonal titanium dioxide 89 to 4920. And the same images shows the morphology of synthesized titanium dioxide, which is in a rutile one, and the sizes vary from 1 to 100 micrometer. Let us see about the catalytic activity of titanium dioxide semiconductor. We perform a reaction without the presence of catalyst at 180 degrees Celsius. We didn't get any increase in the product yield. Hence, we try the reaction with the presence of titanium dioxide catalyst under different solvent conditions. At particular solvent, we will able to get the maximum yield of 85% of the product. Hence, this catalyst is used as a best for this synthesis of benzyl hydroxide derivatives. The special characteristics are using this catalyst, we will able to obtain a very high product yield, and it give a shorter reaction time, and it allow only a low catalyst to perform the reaction. Hence, this method is simple and more convenient. This table shows the effect of catalyst and temperature in the synthesis of benzyl hydroxide derivatives. We perform the reaction with the different types of solvents. By using ethanol, we will able to get an yield at maximum of 85%. 85%. Hence, ethanol is the best solvent for the synthesis of benzyl hydroxide derivatives. This figure shows the reusability of titanium dioxide for catalytic synthesis of benzoyl hydroxide derivatives. We are reuse this catalyst for the synthesis of compounds from 1 to 4. During synthesis, we didn't observe any loss in the significant activity of the catalyst. Hence, this catalyst holds good for the synthesis of benzoyl hydroxide derivatives. This image shows the zone of inhibition of compounds 1 to 4 against bacterial strains. And this image shows the zone of inhibitions of compounds 1 to 4 against antifungal strains. The synthesized compounds 1 to 4 are examined for antibacterial activity using this diffusion method. Here, the ciprofloxacin and amphotericin B are used as a standard for both bacterial and fungal studies. As a result, the compounds 2, 3, and 4 exhibit considerable inhibition activity, whereas compound 1 didn't show any inhibition activity against the bacterial strains. For fungal strains, the compounds 1, 2, 3, 4 exhibit moderate to maximum activity. The compound 1, 2, 3, 4 shows more antifungal activity than the antibacterial activity. The compound 4 shows excellent antifungal and antibacterial activity due to the presence of the methoxy group. This figure shows the HOMO-LUMO orbital picture of compounds 2 to 4. So we optimize the structure using DFT-B3-LIP method using 631GTP as a basic set. And then once we obtain the optimized structure, we perform the HOMO-LUMO orbital for these compounds. From that, the electron density of a HOMO-LUMO molecular orbital of the molecules 2, 3, and 4 contributed the entire molecule except the methyl substituted aryl ring. HOMO molecular orbital picture of all molecules shows that the bonding character is more in the aryl ring, whereas anti-binding character is more in the LUMO orbital of 2, 3, and 4. The energy gap value shows that all the synthesized molecules are polar and intramolecular charge transfer takes place within the molecule. Conclusion. So synthesis of benzoyl hydroxide derivatives using sol-gel synthesized titanium dioxide nanocrystal as catalyst. Compounds 2, 3, and 4 show considerable inhibition activity against the testal bacterial strains. Compounds 1, 2, 3, and 4 indicate that all the compounds exhibit moderate to maximum activity against the reported fungal strains. The homomolecular orbital pictures of 2 to 4 shows that the bonding character is more in the aryl ring, whereas anti-bonding character is more in the LUMO orbital. Thank you.
Thank you, ma'am, for your excellent presentation. Here comes T.S. Vijita, Idaya College for Women, Pondicherry, Department of Biochemistry, to give her presentation on Moringa oleifera household alternative covalent for water treatment.
We video. A very warm greetings to one and all out here. We, the students of Department of Biochemistry from Idea College of Arts and Science for Women, Puducherry, here to present our research work on the topic, a comparative study of alum and Moringa oleifera in wastewater treatment at household level. Next slide. To begin with, the wastewater are treated by several methods such as physical method, chemical method, and biological method through sedimentation, filtration, and disinfection, and it is often treated by chlorine also. The wastewater treatment was founded by PV in 1995. Nowadays, the recent studies have pointed out several serious drawbacks of using aluminum salts to treat water. Next slide, ma'am. The Moringa oleifera is a tropical plant which belongs to the family Moringaceae. There are several forms of Moringa oleifera, such as Moringa oleifera pods, Moringa oleifera shell seed, and Moringa oleifera press cake. The seeds of Moringa oleifera are brown in color, and the kernels will be in white crushed whole seed, or the press cake is obtained after oil extraction as a coagulant for water, which is used for wastewater treatment. Next slide. The purpose of this study is when the higher concentration of alum is needed, the lime is also added to the water, which increases the pH that facilitates the treatment. The cost of these chemicals is increased rapidly, and most developing countries are finding it difficult to cope up with it. So, if there is a cheaper alternative, even the less developed countries will get the chemicals or further alternatives to treat the wastewater. The drawbacks of alum are the aluminum is treated. Next slide, ma'am. The drawbacks of alum are if the aluminum is treated with wastewater, it leads to Alzheimer's disease and several health related problems. It also produces large sludge volumes, and the pH alkalinity adjustment is required here. Low efficiency in coagulation of cold water, and it is too costly and require high foreign exchange. Next slide, ma'am. The advantage of Moringa oleifera over alum are, we all know that Moringa oleifera is natural and it is completely non-toxic, and it does not need any pH alkalinity adjustment. It reduces the level of microorganisms in water, and it is completely biodegradable. And the volume of sludge which is produced in case of moringa is less than that of alum. The drawbacks of Moringa oleifera are the availability of seeds are not sufficient, so that we need uh, mass cultivation of Moringa oleifera trees. The cost of shelled seed powder of Moringa oleifera is higher than the cost of alum. If the water is treated by Moringa oleifera, it produces odor after 2 days from treatment, and it also increases dissolved organic carbon in treated water. Next slide, ma'am.
The aim of the study is to comparison of alum and Moringa oleifera seed extract to treat wastewater. Objectives are to optimize the coagulation dose, flow, and rapid mixing parameters to improve the extraction method of coagulation active compound, to study the household alternative coagulant for wastewater treatment. Next slide, ma'am. Materials and methods we have used are entire study was divided into the different stages, and the same experiment is repeated for 3 coagulants: Moringa oleifera shelled blended water extract, Moringa oleifera shelled blended oil extracted water extract, and alum. Next slide, ma'am. A series of experiments was conducted on 3 synthetic raw water turbidites, 50, 150, and 450 NTUs. Residual turbidity was used as a parameter to judge the performance of the process. Next slide, ma'am. To, to, to find out the seed analysis, we have followed the test methods likewise, and we found the parameters like proteins 36.90% and fat 37.25% and carbohydrates 16.38%, crude fibers 12.85%, moisture 6.41%, and hashes 3.6%. Next slide, ma'am. We prepare the seed extract by grinding the shelled or non-shelled seeds, and also used the powder forms it's dissolved in the water, and we prepare the seed suspensions. Next slide, ma'am. We also prepared a synthetic turbid water by using the kaolin clay is mixed with the 500 ml of distilled water, and the solution was allowed to stand for 24 hours. The stock solution turbidity varies from 50 to 450 NTUs, prepared by serial dilution of stock solutions. We used the equipments like jar test apparatus. It is also known as the focculator. It is used to mix the mixture uniformly. Next slide, ma'am. Digital Lowy board turbidity meter is used to measure the turbidity of the water, and we use the digital pH is to measure the accurate amount of pH in the water, and rabbit mixer is a tool used in the laboratories for the water treatment. It mixes the mixture vigorously and before treating it is into the focculator.
Here we can see observation and data interpretation. In this observation, there are 2 bottles. One is filled with flocculated water, and the other one is filled with non-flocculated water, which means clear water. That clear water is treated by the means of Moringa oleifera seed extract. Next, ma'am. Here in the first test result was in the form of graphical method. Optimum dosage of Moringa oleifera shell blender was able to achieve 63.90% turbidity removal at an optimum dosage of 70 mg per liter for 50 NTU. Within 30 mg per liter of Moringa oleifera seed extract to clear turbidity removal of 93.10% respectively. Next, ma'am. Then the next test result is of optimum dosage of Moringa oleifera shell blended oil extracted. Oil extracted in the sense a press cake of Moringa oleifera seed. Shell blended oil extracted Moringa oleifera was able to achieve 78.7% turbidity removal at an optimum dosage of 50 mg per liter for 50 NTU. Then 100 mg per liter for 83.24 turbidity removal and 150 mg per liter for 94.22 turbidity removal. Next, ma'am. Then the test result for optimum dosage of alum. Alum was able to achieve 92.47% turbidity removal at an optimum dosage for 30 ml. This also clear the turbidity level up to 98.40% respectively. Next, ma'am. As a summary result of all these three tests, we can comparize optimum dosage level with reduction in turbidity level up to 300 to 93.1% turbidity clearance in shell blended water extract, and on Moringa oleifera shell blended oil extract we can gain optimum dosage of 150 mg per liter. It gives a reductive in turbidity up to 94.22%. Next, ma'am. Next slide, ma'am. As a conclusion, Moringa oleifera seed present a viable alternative to alum. Increased dosage of Moringa oleifera leads to decreased turbidity up to the optimum dosage, after which the residual turbidity increases due to floc restabilization, increasing initial turbidity. Optimum dose is subsequently found to increase. Requirement dose for Moringa oleifera for both shell blended and shell blended oil extracted was higher than alum. All over the turbidities range from 50 to 450 NTUs. Next, ma'am. The oil content in the seed will form an emulsion or a film coating which may inhibit the contact with the surface of reaction and thus reduce floc formation. Shell blended oil extracted Moringa oleifera has been found to be more effective than the shell blended seed as a primary coagulant for turbid water. It is easy to prepare the suspension and can be used as a household water treatment. Next, ma'am. Moringa oleifera seed contains 40% oil by weight, and hence after oil extraction waste product, press cake contains an active component affecting coagulation in water treatment. Therefore, farmers can promote for cultivation. Using Moringa oleifera as a replacement coagulant for proprietary coagulant meet the needs for water technology in developing countries, which is simple to use, robust, and cheap to both install and maintain sustainable as household coagulant. Next, ma'am. Moringa oleifera is a consumer friendly and environment friendly low alternative for rural areas or small scale water treatment plant. Moringa oleifera is a renewable resource, can be grown on large scale. As a end, research should therefore continue in this area so as to apply it to small and large scale water treatment in tropical development countries. Thank you.
Thank you, Vijita, for your wonderful presentation. Now I call upon J. Bhavani, Department of Chemistry, to present her topic about electrosynthesis, characterization of 2-ethoxybenzoic acid at platinum electrode by potentiostatic method.
Good afternoon, everyone. I am Bhavani from Department of Chemistry, and I am going to present on
electrosynthesis and characterization of 2-ethoxybenzoic acid at platinum electrode by potentiostatic method. Introduction. Electrochemical reaction. Electrochemically formed products are known for their high grade of purity and selectivity. Electrochemical reactions are formed to be of least pollution. Importance of benzoic acid. Benzoic acid is mainly used for the synthesis of analgesic and antipyretics. They are also precursors for synthesis of many plastices, sodium benzoate, and other preservatives. Measurements. Cyclic voltammetric studies have been carried out using VESA SAT3, Amtech, Princeton Applied Research, USA. For the 3 electrode assembly, platinum plate as working electrode, platinum wire as auxiliary electrode, and silver chloride were used. Chemicals. Solutions were made with double distilled water. 1M solutions of electrolytes such as sulfuric acid, potassium chloride, potassium hydroxide were freshly prepared and used. Synthetic methodology. The supporting electrolyte and the pH of the medium were changed by introducing 1M solutions of sulfuric acid, potassium chloride, and potassium hydroxide into the mixture of solutions of benzoic acid and solutions of ethanol. The pH of the medium were changed. Resultant discussion. The cyclic voltagrams CV of benzoic acid is reaction mixture is recorded in acidic, neutral, or basic conditions to find out the oxidation potential. The CVs recorded in neutral and alkaline media are found to be of the same pattern without much variations. But a variation is observed in CV recorded in acidic medium. This is due to the involvement of protonated water molecules. From this, it is concluded that the mechanistic pathway of aromatic radical cation formation is the same in neutral and alkaline media. Scan rate variation studies. From the CVs recorded at 5 different scan rates, it is found out that the anionic peak current is proportional to the square root of the scan rate. Multiple scan studies. This technique is applied to ascertain the probability of formation of polymers on the electrode surface. If polymerization is possible, an anionic peak current will be present in the first scan. At this, potential polymerization will take place and a film will be formed on the electrode and the peak will be missing in the subsequent scans. Polarization studies. From the polarization studies, the working or decomposition potential of benzoic acid were found out. On graphite and platinum electrodes or dipped into benzoic acid in acidic or neutral or alkaline form will have the various working potential. FT IR spectrum of ethoxylated benzoic acid. The electricity was passed to the reaction mixture at a constant oxidation potential using platinum as anode by potentiostatic method. The product formed was purified, separated, and characterized with conventional spectral techniques. On the basis of the mass spectrum, the molecular formula of the compound was found to be C9H12O3. The presence of OH group of carboxyl group and the absorption peak at 3252 cm per minus 1. The presence of CH of the carboxyl group and the absorption peak at 2983 cm per minus 1. The presence of CO of carboxyl group and the absorption peak at 1026 cm per minus 1. Proton NMR spectrum of the ethoxylated product of benzoic acid. CH3 proton appeared as triplet at 1.5 ppm and CH2 proton appeared as quartet at 4.3 ppm. The OH proton appeared at broad singlet at 10.9 ppm. The aromatic proton adjacent to carboxyl group attached to carbon appeared as doublet at 8.0 ppm. The proton adjacent to ethoxy group also gave a doublet at 6.9 ppm. The remaining two aromatic protons gave peaks at 7.0 ppm and 7.5 ppm. Conclusions. The following are the conclusions arrived from the observations. The process is diffusion controlled on platinum electrode. The oxidation is irreversible. Orthosubstituted ethoxybenzoic acid is obtained with little byproducts. Thank you all. Thank you, Bhavani, for your marvelous presentation. Next, I would like to invite A. Vijayalakshmi, Idaya College for Women, Pondicherry, Department of Biochemistry, to present her topic about isolation, identification, and analysis of phytoconstituents.
Good evening, everyone. I like to start my presentation with a beautiful quote: plant a tree and plant a new life. We from the Department of Biochemistry from Idaya College of Arts and Science here to present about the study on separation, direction, characterization, and examination of pharmaceutical phytochemical. The main aim of this study is to make use of the natural medicine which is gifted by the nature than the artificial or chemical drugs which causes many side effects to the human body. We all know that the plant prepares the food from the solar energy, and it synthesizes many metabolites which is also called as phytoconstituent, which are helpful for the human diseases, for curing human diseases. We have isolated some of the phytoconstituents that are curcumin, artemisinin, atropine, citral, menthol, caffeine, and reserpine. Next slide, ma'am. Curcumin. The curcumin or curcumoid or the dairy haploid compound obtained from the dried rhizome of turmeric powder, Curcuma longa. It is from the family Gingiparaceae. It is a major coloring principle which gives color to the product. It is the mixture of curcumin, monodismethoxycurcumin, and bis-dismethoxycurcumin. Next slide, ma'am. It is orange yellow in color. It is in the form of crystalline powder. It is insoluble in water and ester, and it is soluble in alcohol. It is mainly used for the wound healing, and it is very much used against the peptic ulcer. Next slide, ma'am. So then we can going to see about the extraction and isolation. It is a simple method in which the turmeric rhizome is washed and dried in the sunlight over 10 to 15 minutes. Then the following material is taken into the process of milling, and then we got the powder, and it is treated with the acetones and the menthol in the ratio of 1:2. Then the filtration process is continued. Then the filtrate is taken. The filtrate thus obtained is called the turmeric colyrosin. Then it undergoes the crystallization process from which we obtain the curcumin powder. Next slide. Next, the identification and analysis. We identified and analyzed by the TLC method, like a thin layer chromatography method. In this, we prepared the sample preparation by dissolving 1 mg of curcumin in 1 ml of methanol. Then we used as the standard phase as a silica gel G, and the mobile phase as chloroform ethyl glacial acetic acid in 94:5:1. And we detected again under the UV light at 360 nanometer, and we found the retardation factor value for the curcumin is 0.79. Next, ma'am. The next phytoconstituent is artemisinin. It is also called xanthonica. It is a sequester terpenoid lactone. The sequester terpenoid lactone, or a group of secondary metabolites found across the plant kingdom, comprising a large group of over 5,000 known components, and it is obtained from the unexpanded flower head of Artemisinin annuae. And the family of this plant is the Compositae, and it used as an anti-malarial drug. It is in the form of crystalline powder, and it is soluble in organic solvent. Next slide, ma'am. The extraction and isolation of this artemisinin is, the leaf of the artemisinin is dried and powdered, and it is extracted with the petroleum ether, and then it resolved in chloroform. Acetonitrate is added to precipitate sugar and vaccine. Then the filtration process is carried out. Then the filtrate is taken. Next slide, ma'am. Then the fraction containing artemisinin could be crystalline from cyclohexane or 50% of ethanol. Thus, we got the artemisinin. Next slide, ma'am. Then analysis and then we say, like the same process, we are dissolving the artemisinin in 1 ml of the chloroform, and we have chosen the stationary phase as silica gel G and the mobile phase as petroleum ether and ethyl acetate in the ratio of 1:2. And the standard, for the detecting the, we have used the detecting agent p-dimethylaminobenzoaldehyde and heated at 80 degrees Celsius to produce color, and the RF value thus we got is 0.67, which is compared with the standard artemisinin. Next slide, ma'am. Next, the third phytoconstituent is atropine. Atropine is a tropine alkaloid obtained from Atropa belladonna. It is from the family Solanaceae. It is used as antispasmodic and mydedic, etc. Next slide, ma'am. The atropine, the isolation and extraction of the atropine is, we have taken the powder of the Atropine belladonna and is treated with Na2CO3, which is the sodium carbonate, and it is extracted with ether and aqueous acetic acid. Then the acetic aqueous layer is separated. Then it is again treated with the sodium carbonate. Next slide, ma'am. Next slide, ma'am. Next slide, ma'am. Okay. Then the terphenol alkaloid get precipitate, filtered, and then it is dried. Then the dry powder is treated with diethyl ether, and the concentration of the filter thus obtained contain the crystals of atropine. Next slide, ma'am. Okay, so there are many alkaloids. So for the detection of the atropine alkaloid, the chemical test is done. Whittle-Morton test. We have taken the small quantity of the solid atropine and we added concentrated nitric acid in an evaporating dish, and we kept in the water bath. Then we added 1 ml of acetone and a freshly prepared potassium hydroxide solution. Thus the violet coloration take place. This indicates the presence of atropine. Next slide, ma'am. Then after we followed the TLC method, thin layer chromatography method. For the sample preparation, we dissolved 1 mg of in 1 ml of chloroform. The stationary phase we took as silica gel G, and the mobile phase as toluene, ethyl acetate, and diethylamine. The detecting agent is a Daendorf reagent to produce yellow color spots. The RF value which we obtained is 0.70, which is compared with the standard atropine. Next slide, ma'am. Then the fourth phytoconstituent is citral. The citral is the monoterphenol aldehyde found in variety of source like lemongrass, lemon, and orange peel. The citral contains a mixture of two geometric isomer, geranyl and niral. Next slide, ma'am. These two components are light oily liquid with lemon odor. It is insoluble in water but miserably soluble with alcohol, ether, benzyl, benzonidate, etc. Next slide. The isolation and extraction of these citral is the fresh plant is hydrodilled to obtain lemongrass oil. Then it is followed by fractional distillation. To the total oil, we added the sodium sulfide, and then the citral is crystallized. Then the crystals are washed with the chloroform, and the products is then subjected to sodium carbonate to recover the citral. Next slide, ma'am. TLC. Then we carried out the thin layer chromatography method. The sample presentation, 1 ml of the citral is dissolved in 1 ml of methanol. Then the stationary phase we took as same as the silica gel G, and the standard sample is citral. And we use the mobile phase as pure chloroform, and the detecting agent as 2,4-dinitrophenylhydrazine reagent. Ma'am, before slide. Reagent to produce yellow color spots, and the RF value thus obtained is 0.51.
So let us move to the next phytoconstituent, menthol. So menthol is acyclic monoterphenol alcohol, which is obtained from different variety of mint oils or peppermint oils. So it consists of a fresh flowering tops of Mentha piperita, Mentha officinalis. So this comes from a family called Labiatate. So the granular substance are crystalline with peppermint taste and odor. So freely soluble in alcohol, chloroform, ether, petroleum ether. Next slide, ma'am. So the extraction and isolation. So we took the accurately weighed quantity of coarse powder of Mentha piperita parts just before flowering. So we extracted the peppermint oil by water distillation method, and we separated the oil and allowed cooling. The crystals of menthol will be separated out. So we collected the crystals by centrifugation method, and also we recrystallized menthol from acetone or any other low boiling point solvent. Next, ma'am. Next. So the identification and analysis, we did it by thin layer chromatography method. So we took the sample of preparation by dissolving 1 milligram of menthol in 1 ml of methanol. So we took the stationary phase as silica gel, mobile phase of pure chloroform, and we detected the agent as 1% of vanillin sulfuric acid reagent and heated the plate at 110 degrees Celsius for 10 minutes. So the RF value we got is 0.48, 0.48 to 0.62. Next slide, ma'am. So the next phytoconstituent is caffeine. So a caffeine is a purine alkaloid obtained from a source of tea leaves, coffee seeds, cocoa, and other species. So it also treated for, so we can use it for the adenosine stimulant. So the biological source for it consists of dried leaves of plant known as Thea sinensis. So the family is Theaceae. So it is chemically 1,37 trimethylxanthine. So which is isolated from tea and coffee seeds during decaffeination process. So the tea leaves contains 1 to 4% of caffeine and coffee contains 1 to 2% caffeine. So it is a white powder or white glycerin needles, which is odorless, bitter in taste, and is also soluble in hot water. Caffeine is a central nervous system stimulant and diuretic. Next slide, ma'am. So the extraction and isolation. So this source powder tea leaves is extracted with boiling water and the aqueous extract is filtered while hot. So this warm extract is now treated with the lead acetate to precipitate tannins and filter. So this filtration is now treated with the excess of dilute sulfuric acid to precipitate lead in the form of lead sulfate. So next slide, ma'am. So this filter is collected and filtrated. The filtrate is boiled with activated charcoal to remove coloring matter. So, and the filter is removed by the charcoal. The filtered decolorized solution is extracted with chloroform successively. So we combine the chloroform extract and evaporate on a water bath to yield caffeine, which is a white powder. It is recrystalled with alcohol. Next slide, ma'am. So we identified and analyzed with the chemical test called Muraxid test. So this caffeine is added with the hydrochloric and potassium chlorate, and this is heated to dryness. A purple color obtained by exposing this residue to vapors of dilute ammonia. So we next did the method. Next slide, ma'am. This we use a sample preparation by dissolving 1 milligram of caffeine in 1 ml of methanol or chloroform. We took the stationary phase as silica gel and the mobile phase as ethyl acetate, methanol and acetic acid in the ratio of 80:10:10. So we detect the agent by exposing the vapors of iodine. So the RF value which we got is 0.41. Next slide, ma'am. So the next phytoconstant is rizapine. So this rizapine is an indole alkaloid obtained from the roots of Rauwolfia serpentiana. So the family is Apocyanaceae. So it is a white or pale buff to slightly yellow odorless crystalline powder. It is soluble in alcohol, acetone, and chloroform. So this rizapine is an anti-hypertensive and antipsychotic agent. Next slide, ma'am. So this is extracted and isolated now. So this source Rauwolfia powder is exhaustively extracted with 90% of alcohol by peat collation. The alcoholic extract is concentrated and dried under the pressure below 60 degrees Celsius to yield the Rauwolfia dry extract. So this dry extract is extracted with the ether chloroform on the 90% of alcohol in the ratio of 20:8:2.5. So the extract is collected and the dilute amount of ammonia is added with the intermittent shaking and the water is added along with the drug to settle after vigorous shaking. Next slide, ma'am. So the filter of the solution is extracted with the residue and the volume of pore 0.5 and ammonium sulfate is separated the separated funnel and combined all the extract. So this extract is made alkaline with the dilute ammonia to liberate alkaloid. Finally, it is extracted with the chloroform. So we collected the chloroform extract and concentrated and evaporated on water bath to yield total Rauwolfia alkaloids, which we obtain 30 different components. So again, we use the column chromatography fraction for the separation of rizapine. So the next slide, ma'am. So we identified and analyzed the TLC method. So here we took the sample by dissolving 1 milligram of rizapine in 1 ml of methanol or chloroform. So we took the standard sample as rizapine and the mobile phase chloroform, acetone and diethylamine in the ratio of 50:40:10. And we took the detecting agent as a Dregendorf's reagent and we got the RF value as 0.72. Thank you, ma'am.
Thank you, Vijayalakshmi, for your amazing presentation. Now I would like to call Dr. S. Sivapriya, Assistant Professor, Department of Chemistry, to present a topic about synthesis characterization, DFT studies, and anti-cancer activities of novel spiro compound.
Everyone, I am Sivapriya, Assistant Professor, Immaculate College for Women. Now I present about synthesis, characterization, DFT studies, and anti-cancer activities of novel spiro compounds. Green chemistry is the design of chemical products and processes that reduce or eliminate the use of generation of hazardous substances. Synthesis of organic compounds using eco-friendly method with low cost, low energy consumption, and to minimize byproducts and waste materials. Cancer is a heterogeneous disease with uncontrolled cell growth that has much influence in the normal cells, molecules, blood vessels, which results in tumor. The tumor may develop and metastasize to other locations of the body and interfere with all the biological systems that changes the function of the body. Chalcones are nothing but 1,3 diaryl plug 2 in 1 ounce, which are interesting class of compounds that occur naturally and exhibit extensive attention for several years due to their simple structure and diverse pharmacological activities. For the past few years, chalcones have been described to possess valuable, innumerable properties like anti-cancer, antimicrobial, anti-inflammatory, etc. Based on the pharmacological properties of these compounds, I have decided to synthesize chalcone with spiro compound which have more potent biological activities. The schematic representation of the synthesis compounds is shown here. Adding a mixture of acetophenone, benzo-C125 oxidizole, 4-carbaldehyde in the presence of sodium hydroxide and ethanol to give chalcone. In the second step, chalcone reacts with isatin and proline in methanol medium reflux at 48 hours. The reaction mixture was monitored by TLC. The product was extracted using ethyl acetate and dried, recrystallized using acetonitrile. It gives excellent yield, that is 80 to 85% yield. Its molecular formula is C15H10N2O2. Its melting point is 130 to 132 degrees Celsius. Analytical techniques used for the characterization of the synthesized compounds. First one is FTIR spectroscopy, NMR spectroscopy, that is a H1 NMR spectrum, C13 NMR spectrum, and depth spectrum, DFT calculations, finally anti-cancer activity. Plate 1 shows the FTIR spectrum of compound 6. IR spectrum is used to predict functional group of the synthesized compounds. Here, the C double bond O stretching frequency appeared at 1719 cm inverse and NC double bond O stretching frequency appeared at 1677 cm inverse and NH stretching frequency appeared at 3233 cm inverse. The aliphatic and aromatic stretching frequency appeared at 2916 and 3060 cm inverse. Plate 2 shows the H1 NMR spectrum of compound 6. H1 NMR spectrum is used to predict number of protons present in the structures. Here, H7- protons appeared as multiplied at 1.77 and 1.90 ppm. H6- protons appeared as multiplied at 1.85 ppm. The NH protons appeared as singlet at 8.07 ppm. The other aromatic protons appeared around 6.50 to 7.99 ppm. Plate 3 shows the C13 NMR spectrum of compound 6. C13 NMR spectrum is used to predict number of carbons present in the structure. Here, the C double bond O carbon appeared at 180.85 ppm, NCO carbon appeared at 197.22 ppm. The other aromatic carbons appear around 110.46 to 140.79 ppm. Plate 4 shows the depth spectrum of compound 6. Depth spectrum is used to distinguish between carbon with an odd number of hydrogen atoms and even number of hydrogen atoms. Carbon with an odd number of hydrogen atoms will point upwards in the direction and carbon with an even number of hydrogen atoms will point downwards in the direction. Here, the methane carbons will point in the upward direction and methylene carbons will point in the downward direction. The quaternary carbon, that is C3-, do not appear in the depth spectrum. All the characterization gave the expected structure was formed Then the next studies is theoretical studies. Theoretical calculation was done by using Gaussian software at B3LOIP 631G DP basic set. Optimal structure of the synthesis compound used give minimum energy of the synthesized compounds. Frontier molecular orbital is used to predict chemical reactivity of the synthesized compounds. HOMO is nothing but highest occupied molecular orbital and LUMO is nothing but lowest unoccupied molecular orbital. The energy gap difference between the HOMO and LUMO is 2.36 electron volt. This small energy gap indicates the eventual charge transfer taking place within the molecule. MEP images of compound 6. MEP is used to predict electrophilic and nucleophilic reactivity of the synthesized compounds. Here, the red color represents the negative region which prefers the electrophilic reactivity, and the blue color represents the positive region which prefers the nucleophilic reactivity. The remaining green color represents the zero potential. From the title compound, the C double bond O carbon appear in the negative region and the spiro compounds will appear in the positive region. Mulliken plot of compound 3A. Mulliken population analysis is an important quantum chemical calculations. Here, all the hydrogen atoms carrying a positive charge and nitrogen and oxygen atoms carrying a large negative charge. This large positive and large negative charge indicates electrophilic and nucleophilic substitution reactions are favor for the title compound. NLO analysis of compound 6, the polarizability and hyperpolarizability values are greater than that of the compound. Hence, we can close out that the compound is best NLO material in future. Anti-cancer activity of the synthesized compounds was done by using MTT assay. MTT is nothing but is an yellow formation. MDA-MB 231 cell line is an human breast cancer cell line. Which compound having least IC50 value, that compound will be more active. Here, 31.25 micromolar is enough to kill the cancer cells. Finally, I have successfully produced a highly selective one-part multi-component method for the synthesis of novel spirobrezolidine compounds. The structure of the synthesized compound is confirmed by FTIR spectroscopy, NMR spectroscopy, C13 NMR, H1 NMR and depth spectrum. The theoretical calculation was performed using Gaussian software. The anti-cancer activity of the synthesized compound evaluated against MDA-MB 231, that is breast cancer cell line, anticipated that the compound was the potent candidate. As a result, the newly synthesized compounds are biologically stable and have the potential to be employed as therapeutic agents in future drug development trials. Thank you.
Thank you, ma'am, for your fantastic presentation. Now I call upon M. Maladi Nachiyar, Idaya College for Women, Sarogani, Ramnath District, to present a topic about FTIR and GCMS, analysis of methanoic leaf extract of Evolvulus alzinoides.
Good evening, everyone. I am Maladi Nachiyar, Department of Biochemistry, Idea College from Women, Sargani. Today, I am going to present this topic is FTIR GCMS analysis of methanoic leaf extract of Evolvulus alzinoides. My topic is FTIR GCMS analysis of methanoic leaf extract of Evolvulus alzinoides. Next slide, ma'am. Medicinal plant is an important component of the healthcare system, and their secondary metabolites is a many used for many drugs. And then bioactive components are the essential for human health and biological importance of the effect. Next, ma'am. I taking the medicinal plant is Evolvulus alzinoides is an important popular Ayurvedic drug used to improve the intelligence of the memory and the higher mental functions. It is a best tonic for a brain and nerves, and then metal nanoparticles are the great importance to their higher surface area and then high fraction of the surface atoms. Gold is a powerful agent for the killing unicellular microorganisms and the strongest antimicrobial effect. Next, ma'am. Characterization analysis is a GCMS analysis. GCMS is a gas chromatography and mass spectroscopy. Hyphenated technique is used commonly for a identification and quantification purpose. And then mass spectroscopy analysis each component of the separately. Next, ma'am. FTR mainly used for identification and characterization of the materials, and then identify of types of functional groups, and then surface absorption of the functional group on the nanoparticles. Next, ma'am. Coming to the objectives, to estimate the synthesis of evolved alginoids derived from the gold nanoparticles for the medical application, and then to determine the bioactive components in the evolved alginoids in the leaf extract using GCMS technique, and then GCMS technique usually analyzes the bioactive components of the whole plants. Next, ma'am. Coming to the methodology, to collect and processing the plant materials, and then washed with the distilled water, and then extraction of the plant samples, and followed by the phytochemical screening, and then followed by the FTIR spectroscopic analysis is followed by the GCMS analysis. Next, ma'am. These are all the overall process of these studies. First of all, medicinal plants is derived from the gold nanoparticles and followed by the FTIR analysis and GCMS analysis. Next, ma'am. And FTIR spectroscopic analysis, first of all, extract were examined in the FTIR spectroscopic analysis and then centrifuged by the 3000 RPM for 10 minutes, and then wavelength ranging is 200 to 1000 nanometers, and FTIR mainly analysis for to detect the characterization peaks and then functional groups. The peak values FTIR is recorded and each and every analysis, and they repeated by the twice time spectrum confirmation. Next, ma'am. Ma'am, next slide, ma'am. Coming to the result, these are all the qualitative phytochemical results of the evolved alginoids in the leaves. First of all, I taking the 4 types of extraction method before for a comparison studies. These are all the ethanol extract, methanol extract, chloroform extract, and aqueous extract. Mainly, methanol extract is a better extract for others. And mainly, methanol extract present in the secondary metabolites are and present in the many mode. Next, ma'am. These are all the 4 types of extraction method: aqueous extract, methanolic extract, ethanol extract, and chloroform extract. Next, ma'am. These are all the FTIR peak of the FTIR analysis peak. First of all, highest peak range denote the sketch of the vibration, and then intensity is strong, and functional group present in the medicinal plant is OH hydroxyl group, and then strongest intensity is a high sulfosides, aliphatic amines, aliphatic alkynes, aromatic alkynes, and alkene halides. Next, ma'am. These are all the peak value of the FTIR analysis. This picture is denote the highest intensity and the highest stability of the FTIR analysis. Next, ma'am. This shows the GCMS analysis of the evolved alginoid. This denote the retention time, high retention type, high solubility denote the high anti-diabetic and anti-cancer activity. Next, ma'am. Retention time is between the interval between the injection of the sample and then detected by the substance. High retention time denote the height of the peak, and then anti-cancer activity, anti-accident, and anti-inflammatory activity. Height is ranges to 29.35, and then 5.85 is the highest range for retention time. Next, ma'am. These are all the bioactive components present in the evolved alginoids, and then biological activities. Components are the N-hexadeconic acid, methyl ester, heptadecone, and D-allose, and the cytidine on the component of the bioactive component are present in the alveus alginoid, and then biological activity is the antioxidant, antimicrobial, anti-inflammatory, and then inhibitor of this alpha reductase. Next, ma'am. Coming to the conclusions of the study. First of all, medicinal plants is the backbone of the traditional medicine, and then identification and bioactive components of the evolved alginoid is denoted by the 25 bioactive components present in the present in the plants and denote the deconic acid, hexadeconic acid, methyl ester, D-allocysteine are the present in the medicinal plants in antioxidant, antimicrobial, and anti-inflammatory effect in the present study to denote the to denote and serve as the new potential source of the medicine due to presence of phytochemical and bioactive components. Thank you. Thank you for giving me opportunity, ma'am.
Thank you, Maladi, for your wonderful presentation. Next, I would like to call upon Ms. S. Jayashree, Department of Chemistry, to give her presentation on preparation and characterization of titanium dioxide and barium titanate nanoparticles by Sol-Gel method.
Good evening, one and all. My name is S. Jayashree from Department of Chemistry. Today, I am going to discuss about preparation and characterization of titanium dioxide and barium titanate nanoparticles by Sol-Gel method. Barium titanate was first discovered in United States by Weiner and Solomon in 1942, by Russia Wool in 1944, and in Japan Ogawa in 1994. Barium titanate powder is used for development of MLCC, multi-layer ceramic capacitor. There are two methods for the preparation of barium titanate powder. There are wet chemical methods and sol-gel method. Preparation methods of barium titanate. In wet chemical method, such as hydrothermal method, is directly synthesized barium titanate powder. It requires relatively harsh reaction conditions, and therefore special and expensive reactors is capable of withstanding high pH and temperature. It is too expensive. In solder process with titanium alkoxide allow for milder reaction conditions. It is too cheap and environmentally friendly. Properties of barium titanate. Barium titanate is an oxide of barium and titanium. It is ferroelectric ceramic material with a photorefractive effect and piezoelectric effect. The appearance of white powder is white to gray in color and has a perovskite structure. It is soluble in many acids such as sulfuric, hydrochloric, hydrofluoric acids, but it is insoluble in alkalis and water. In pure form, it is an electrical insulator, but when it is doped with small amount of metal such as scandium, yttrium, samarium, etc., it becomes semiconducting. As semiconductor, it exhibits positive temperature of coefficient of resistivity properties in the polycrystalline form. Synthesis of nanocrystalline titanium oxide by Sol-Gel method. Titanium dioxide is prepared by hydrolysis of titanium 4 isopropoxide followed by calcination. About 1 milliliter of titanium isopropoxide was dissolved in 20 milliliter of isopropyl alcohol. After stirring water was added to alkoxide solution, the formed white soldier of hydrous oxide was stirred vigorously for 2 hours at room temperature and dried at 100 degrees Celsius and calcinated 500 degrees Celsius for 3 hours. White color powder was obtained and it was used for structural and optical studies. Synthesis of nanocrystalline barium titanate by Sol-Gel method. By dissolving 1 gram of barium nitrate and barium acetate in 20 ml of distilled water and mixed with titanium 4 isopropoxide. After stirring for 30 minutes, 1 gram of polyvinyl pyrrolidone and 1 milliliter of aqueous ammonium were added and continue stirring for 2 hours at room temperature and then allowed to age overnight. It was filtered and washed with water a number of times, then dried it and calcinated. The white color powder was obtained and it was used for structural and optical studies. Next, characterization of titanium dioxide and barium titanate. The synthesized titanium dioxide and barium titanate nanoparticles were characterized by X-ray diffraction. The XRD technique uses the scatter intensity of an X-ray beam on the sample, revealing information about the crystallographic structure, chemical composition, and physical properties. The XRD pattern of pure titanium dioxide and barium titanate nanoparticles recorded in the range of 20 degree to 80 degree, and diffraction peaks at 2 theta as shown in figure. Next, same and EDX analysis of titanium dioxide and barium titanate nanoparticles. Same shows high homogeneity of pure titanium dioxide and barium titanate nanoparticles. Next, the soldier synthesis pure titanium dioxide and barium titanate nanoparticles are determined in irregular shape and it is observed in rod-like structure. In this graph shows the elemental composition was determined by EDX analysis. Conclusion, pure titanium dioxide and barium titanate nanoparticles are determined in irregular shape and barium titanate is observed in rod-like structure. The EDX spectrum has prominent peaks of titanium barium oxygen confirmed by the formation of pure titanium dioxide and barium titanate nanoparticles. Thank you.
Thank you, Jayashree, for a wonderful presentation. Next, I would like to invite M. Gopika, Department of Chemistry, to give her presentation on green synthesis of zinc oxide and silver oxide nanoparticles using Acalipha indica leaf extract and its application.
Good evening to any and all present here. I'm M. Gopika from Department of Chemistry, and here I am today to give a presentation about the topic on green synthesis of zinc oxide and silver oxide nanoparticles using Acalipha indica leaf extract and its application. Introduction. Nanoparticles are solid colloidal particles composed of a synthetic polymer. Nanoparticles are particles between 1 to 100 nanometers in size. Particles are further classified according to the diameter. Nanoparticle research is currently an area of intense scientific research due to a wide variety of potential applications. The interesting and sometimes unexpected properties of nanoparticles is due to the large surface area. Nanotechnology is especially concerned with the synthesis of nanoparticles of variable size, shapes, and chemical composition. Zinc oxide nanoparticles. Zinc oxide powder is widely used as an additive into numerous materials and products. The most common use of a zinc oxide nanoparticles is in the sunscreen. They have a large surface area related to the size and high catalytic activity. The zinc oxide nanoparticles depend on the different ways they are synthesized. Zinc oxide nanostructure. The particle size is dependent on the kinetics of nucleation and growth from a supersaturated solution. They are used because they effectively absorb UV light but possesses to be a completely transparent to the visible light. Silver oxide is the chemical compound which is a black powder used to prepare other silver compounds. It is also known as silver dust, argentous oxide, and silver monoxide. Silver oxide nanoparticles are characterized by applying a manifold available techniques. The silver nanoparticles are added to the filters at all CWF factories to achieve a higher pathogen removal due to their antimicrobial properties. Antibacterial performance in batch phase experiments is evaluated against several water quality parameters. Synthesis of zinc oxide and silver oxide nanoparticles using Acalipha indica leaf. The green route for a nanoparticle synthesis is due to the eco-friendliness, economic prospects, and feasibility. The leaves were washed thoroughly 2 to 3 times with a tap water and then set up the magnetic stirrer and set temperature to 32 degrees Celsius. The flowchart used for the preparation of zinc oxide and silver oxide nanoparticles was shown. The leaves were washed thoroughly with tap water and sterilized with a double distilled water. Then, the sample was allowed to dry in a room temperature at 32 degrees Celsius. And 20-gram bay leaves were boiled with 10 ml of distilled water. While during this procedure, a dark yellow colored solution was formed, and it was cooled at a room temperature and then filter the colored extract using a filter paper and then place in a refrigerator. Take Acalypha indica leaf extract from the solution and boil at a 60 to 80 degrees Celsius. When the temperature reached at 60 degrees Celsius and 2 grams of the zinc nitrate and silver nitrate were added. The mixture was boiled until it formed a golden brown color paste. The paste was transferred to a ceramic crucible and heated in a furnace at 400 degrees Celsius for 3 hours and 600 degrees Celsius for the 3 hours. Structural analysis of zinc oxide nanoparticles. The XRD technique uses the scattered intensity of an X-ray beam on the sample. Zinc oxide nanoparticles recorded in a range of 20 degree to 80 degree. All different peaks attributed with a hexagonal primitive structure. Structural analysis of silver oxide nanoparticles. All diffraction peaks attributed to a crystalline of silver oxide with a cubic primitive structure. The data obtained are in a good agreement with a joint committee on powder diffraction standards JCPDS card for the silver oxide. FESIM with the IREX analysis of zinc oxide nanoparticles. The synthesized zinc oxide nanoparticles seem to be a homogeneous without the presence of other dominating phases. The FESIM images show distinguished spherical morphology. From the IREX spectrum, strong signal is absorbed from the zinc element, light signal is absorbed from the oxygen, magnesium, potassium, and calcium elements. FESIM with IREX analysis of silver oxide nanoparticles. The FESIM images show distinguished needle-like morphology. IREX spectrum shows purity and composition of green synthesized silver oxide nanoparticles. Optical properties of zinc oxide. Large zinc oxide particles. It blocks the UV light and it will scatter a visible light and it appears as a white. Nano-sized zinc oxide particles. It will block the UV light. It is so small compared to the wavelength of visible light that they don't scatter it. And it will appear clear. Conclusion. In XRD spectrum, all the peaks were assigned to a hexagonal primitive and cubic primitive type. FESIM morphology shows the formation of zinc oxide and silver oxide nanoparticles. IREX spectrum confirmed purity and chemical composition of green synthesis of zinc oxide and silver oxide nanoparticles. Thank you all.
Thank you, Gopika, for your stunning presentation. Here comes Ms. V. Monica, Department of Chemistry, to present her topic on enhancement of second harmonic generation efficiency, growth, and its characterization of cobalt studies.
Good evening, everyone. Good evening, everyone. I'm V. Monica from the Department of Chemistry. Here I am today to give a presentation about the topic on enhancement of second harmonic generation efficiency, growth, characterization, and spectroscopy studies of cobalt-2 doped TTNC crystals. Introduction. The development of NLO materials led to its suitability of various applications in frequency conversion, telecommunication, image processing, optical computing, and data storage device. NLO properties of organometallic materials are at present under intense investigation. Synthesis and crystal growth. The purity of the synthesized material was increased by successive recrystallization process. Crystals were grown by slow evaporation solution growth technique. Doping of cobalt 1 to 10% in the form of cobalt chloride was done during the crystallization process. After 20 days, a pale yellow crystals of TTNC were obtained. FTIR spectral analysis. A close observation of FTIR spectra of pure and doped specimens were revealed that doping generally results in small shifts in some of the characteristics vibration frequencies. It could be due to lattice strain developed as a result of doping. The lowering of frequencies can be attributed to the reduced double bond characters of C double bond as bond and coordination. These observations suggested that metal coordinate with a thiourea through a sulfur atom. UV visible spectra. UV visible spectral analysis is an efficient tool to determine the optical transparency of the crystals, an important property for material to be optically active. The UV visible optical absorption spectra were recorded in the range 200 to 600 nanometer for pure and doped TTNC crystals at a room temperature. It appears that the doping does not destroy the optical absorption of pure TTNC crystal. XRD analysis. The pure and cobalt-2 doped TTNC crystals were finely powdered and subjected to powder X-ray diffraction analysis. The sample is of single phase without having any detectable impurity, and the narrow peaks indicates the good crystallinity of the material. SEM-EDS analysis. The investigation of the influence of cobalt-2 doping on the surface morphology of TTNC crystal phases reveal the information of structure defect centers. The particles like morphology on the surface of crystal could be due to surface roughness. The incorporation of cobalt-2 into the crystalline matrix of TTNC was confirmed by EDS. NLO studies. Cobalt-2 doped TTNC has a significant influence on the NLO properties of TTNC crystals. This could be due to effective facilitation of charge transfer in the thiourea complex by the foreign metal ion. It has been reported that the SHG can be greatly enhanced by altering the molecular alignment through inclusion complexation. Conclusion. Single crystals of pure and cobalt doped TTNC crystals are grown by slow evaporation solution growth technique at a room temperature. A close observation of FTIR rates of doped and undoped specimen results the strain developed as a result of doping. The SHG efficiency of TTNC is dramatically increased by heavy doping of transition metal. Thank you.
Thank you, Monica, for your fascinating presentation. The man who interprets nature is always held in a great honor. Now, I request Dr. S. Chandrakumari, Assistant Professor, Department of Chemistry, to welcome the Chief Guest.
Good evening to one and all. Today, a very great day that our international conference on multidisciplinary research goes on a very successful. On this enjoyable occasion, I have the pleasure and privilege of welcoming our chief guest, Professor Sanyasi Erumalai, Director, Dr. ALM Basic Science Development Center, Director Coastal and Ozone Studies, Head Department of Biotechnology, Guindy Campus, University of Madras, Chennai. This one day is not enough me to say about him. I have only very short time. Let I say about him like a keynote. He did his BSc Botany in Government Arts College, Thiruvannamalai from University of Madras. He did his MSc in Presidency College, University of Madras. He did his Master of Philosophy under the research topic Molecular Mycology in Department of Plant Science, Center for Advanced Study in Botany, University of Madras. He did his PhD under the guidance of Dr. N. Raman and Professor A. Mahadevan in Department of Plant Science. He did his postdoctoral research associate with Dr. N. Raman and Professor A. Mahadevan. He has published two scientific reports in Nature Journal. He has published 14 books. He acted as the editor of Pico Technology, Biodiversity, and Biotechnology of Algae and Algae Product book. He received Dr. APJ Abdul Kalam Award, Young Scientist Award, SRF, JRF, and Faizan Award. He has 20 years of teaching experience. He is visiting as a scientist in various countries like Portugal, Germany, Finland, South Africa, Denmark, Sweden, Russia, Hungary, and USA. He gave about 90 invited lecture or presentation in both national and international conference. He has completed 10 research projects by various funding agencies. He has published 9 articles in popular magazines and newspapers. And also he has published 126 research articles. It is important to be a person of honor, then be a person with wealth. No person was ever honored for what he received. Honor has been the reward for what he gave. Now I request our chief guest to give his presidential address.
Okay, very good morning. Good evening. Good evening. Is it audible? Hello?
Yes, sir, you are audible.
Is it
Yeah,
audible,
you can
madam?
go ahead. Yes, sir, you can continue.
Very good evening. Okay. Good evening, everyone. First of all, I would like to thank the organizers of Immaculate College of Arts and Science, especially the college is meant for only women education and women's empowerment. I'm very happy to be along with you. I'm very much delighted this evening to share some of my thoughts. From morning onwards, I'm keenly watching all the presentation from that first presentation by one of the physician doctor and up to the last presentation. So everyone is justified very good presentation and presented a very nice findings along with your experiences. Some of them are very excellent presentations and some of them are average presentations. I have sent the email to the organizers about my evaluation report. So with these few words, I will say something about something new about this recent biotechnological developments. So being a district headquarter based college, the college and the district headquarter, that place itself facing some of the issues and problems. But of course, you are blessed with the neighboring state. Pondicherry is very near to your Kadalur. So you have a lot of opportunities to interact with Central University in Pondicherry and the nearby universities, Annamalai University and other universities. So you have chances to learn more and more what you know so far. So with these few introductory remarks, I will move to my core area like biotechnology. Why do you want to study biotechnology? Biotechnology is not a new subject. It is a combination of subjects like microbiology, biochemistry, molecular biology, botany, zoology, all these subjects. So it is a interdisciplinary, but this is the era of interdisciplinary era. No subject should not be a island. It should be interdisciplinary. Some cases intradisciplinary. In some cases transdisciplinary. So that way, biotechnology is the need of the hour. I think this COVID period, everyone witnessed about the vaccines demand and the related health-related biotechnological tools and techniques, devices, instruments, all these. Especially if you know that test positive, you can immediately go for treatment. But how do you know this test positive or negative? So you go for RT-PCR. So earlier days, nobody knows RT-PCR. Now everyone knows RT-PCR. So this RT-PCR word is in the public domain now. Everyone, even layman can know about RT-PCR. So this is how it is possible because of the biotechnologies. So what we have received 20 seats application, about more than 1,000 applications last year because of this demand. So now everyone realizes the biotechnology is important and core subject when compared to other engineering and medical subjects. Of course, medical is very need of the hour, but biotechnology is one of the inevitable subject. So again, you have different biotechnological applications like marine biotechnology, pharma biotechnology. Morning, one of my best friend, my good old friend, Dr. Prem Kumar, delivered a lecture on space biotechnology. It is one of the interesting topic. And Dr. Prem Kumar and myself, we are friends more than 30 years. And working, Dr. Prem Kumar is working extensively on UVB light and related plant biotechnological transformation and agriculture related issues. Coming to the branches of biotechnology, we have different branches. As I told, Pharma biotechnology, it is need of the hour. Marine biotechnology, why do you want to study marine biotechnology? Because we almost exhausted or exhausting the natural resource from the land resource. So we need to look upon the alternative natural resource in the marine, because what we witnessed during Independence Day is 30 crore people, now 140 crore people. So where are you going to feed these people? So we need to look upon the alternative food feed, even veterinary aspects also. We need to feed millions of cattle and other chick dairy and poultry industries. So these are all related one way or other with biotechnology. So we need to look upon the marine biotechnology based products and a lot of cosmetics, drug molecules, food molecules, feed materials also available in the marine resource. Likewise, pharma industry. Pharma industry, you may think that only synthesis of chemicals are drugs, but it's purely based on natural resource like medicinal plants. As I witnessed many presentations based on medicinal plants. We have more than 55,000 plants in India, but of course we export hardly 15,000 plants and extracts and identification of molecules, identification of new drugs and other active principles. If you explore more and more, you can get wonders. I'll tell one of the recent experience. This Viagra is one of the important, commercially important molecule. But of course, the Viagra's ingredients are from some of the fungus called Cordyceps. In the Himalayan region, we have tons and tons of Cordyceps fungus are growing. If you properly cultivated this fungus, like our mushroom cultivation, you can extract the active principles. This molecule is not only molecule for Viagra kind of nervous stimulating molecule. It is acting like cardio drugs, like treating cardiology related diseases. So we have this kind of Cordyceps like kind of fungus. We have hundreds of fungus, which is still unexplored. Thousands of plants, medicinal plants in the Himalayas, Western Ghats and Eastern Ghats, we are still not explored properly. We are not still scientifically validated. So what we need to do, we need to categorize the biotechnology first, fishery biotechnology, that is aquatic biotechnology, marine biotechnology, pharma biotechnology, plant biotechnology, animal biotechnology, microbial biotechnology, veterinary biotechnology, dairy biotechnology, poultry biotechnology, space biotechnology. So we have n number of subjects which is still unexplored, except hardly very few things in agri-biotech and medicinal plant and so on and so forth. So we need to look upon to explore new things in these areas which I listed now. Then we have to develop some scientific validative principles. We have heaps of molecules and heaps of hundreds and thousands of medicinal plants, fungus, bacteria, everything. So how are you going to get out of the molecule? How are you going to make it commercially viable things? So we need to have a system like supply chain, production, industries. Apart from all these aspects, we need to have a quality human resource like you. So we need to have a proper trained, well-trained, skillful PhDs and master students level, PhD trained, biotechnology trained people. So of course, we are not proportionate quality people. We are not producing in India. Even if we produce some of the skillful, highly skilled and talented people, some of them are going away from India for their perks and other things. So we need to train properly. We need to explore. That is, first one is exploration, both the land, hills, and marine. As far as biotechnology is concerned, then we need to give a proper training and skill development of skills to the PhD and master's level students. We need to supporting system like industries, establishing startups and industries. For example, those days people used to beg jobs, but now I urge upon the youngsters to go for setting up industries, even small industries, even a small, earlier days we used to call cottage industries, but not the word jargon now turned into startups, make in India. There are many programs like Chinese also, they have their own programs. We are almost replicating Chinese and Americans, what they are doing now. So the name may be startup, but earlier it was called cottage industries. But biotechnology is not comes under cottage industry. It needs a skillful person. And the other day, I visited a industry nearby Sriperumbudur. Even our own Chennai, nearby Chennai, we are having a very big and best world class facilities to produce our own vaccines, like the Serum Institute or like the Bharat Biotech. We have in Chennai our own industry. One of the billionaire, he now invested a lot of money on that, and he is setting up a very big fermentor along with vaccine manufacturing unit. So he invested roughly 150 crores on that, and he is having the international advisory panel, including some of them are Nobel laureates, some of them are from Columbia University and Israel-like countries. So what I am saying, we have now opportunities. So instead of going just to simply doing some lab-based diagnostic test like a blood test and other urea test, all this, we need to go into medical biotech. Medical biotech, a lot of opportunities are there. If you have a quality diagnostic lab, you can earn thousands of rupees per day. So likewise, we have, for example, food biotechnology. See, in the recent past, I belongs the northern part of Tamil Nadu. In our districts, a lot of people are just dumping the tomatoes during the harvesting season, just dumping in the ditches nearby canals, because they don't have the proper pricing policy. So how are you going to preserve our storage, like frozen storage godowns? Like how are you going to preserve these tomatoes and vegetables for 1 month? Or see, the shelf life should be extended. See, tomato, if you are not consumed or used within few days, then it will be collapsed or it will be infected by fungus or bacteria. So we need to have a proper cold storage facilities. We need to have a proper harvesting technology, post-harvesting technology, protecting. See, a lot of food corporation of India godowns are rotting, by fungus and producing aflatoxin kind of toxins. So all these things should be arranged in an orderly way. First, to explore the natural resource. What are all the natural resource with reference to biotechnology? Second, you create a atmosphere or conducive atmosphere for the best talented youth, like skillful persons. They are able to produce respective goods. Third one, creation of infrastructure. See, unless otherwise, if you have a talented people without infrastructure, you cannot go for anything, especially with reference to IT and biotechnology. So we need to create a ambience or atmosphere to have a self-satisfied, qualified people along with the infrastructure, world-class infrastructure, supply chain management, godowns, storage facilities, pricing policy. So all these should be arranged in a orderly way or in a regular way. So biotechnology, we have plenty of opportunity, especially fishery biotech. They are exporting millions and millions of tons of fishery products and byproducts from India to other Gulf countries and European countries, and some of the South American countries also. So all these things, our core area is agricultural products. Recently, I have read in news that some of the American states, they are requesting Indian government to send wheat export. They have put a order, millions and millions of tons of wheat, quality wheat, Indian wheat, they need to buy. So agriculture is no more a orphan subject or orphan area no more. If you are a talented scientific way agriculture, if you have, you can make money like anything. For example, poly house based agriculture, like Israel, what they are doing. You put a poly bag, that is poly house, and install the controlled environment like temperature, humidity, moisture, everything. If you sow it like, or if you cultivate this capsicum like or capsicum, coriander or mint, all these kind of plants, every day you can harvest, and it's like a white collar job. Don't think that agriculture is it's a laborious job no more. Now the science and technology is we are exploiting, and we are harnessing the potentials from scientific agriculture. So it's no more a labor oriented job. It's a white collar job. Likewise, if you have a proper godown facility like a cold storage, you can keep your products even for months. Even one of my friend is running a chain of godowns called refrigerated godown, and he's having the tamarind paste and palkova, tons and tons of palkova and tamarind paste meat. So they are exporting through Bangalore airport every day tons and tons of these commodities, these agro commodities and dairy products. And likewise, one of my friend, he installed a mushroom production company in Uttaramerur. In fact, he was a VRS given IAS officer. He started a small mushroom company, but now he is given to 250 employees 6 tons of white mushroom, that is button mushroom, to Gulf countries every day. So afternoon he is harvesting. Early morning it reached all what you call this malls in Gulf countries, all departmental stores. So likewise, we have so many things like biofertilizer, biopesticides, mushroom cultivation, biomolecule extraction, even semi-finished goods also welcoming. Even if you have tons, 1 ton of moringa powder, people are ready to buy. If you have 100 liter of moringa extraction, people are ready to buy. They will purify and they will refine it and they will make it in a final good or commercially viable goods. So we have a range of issues and a range of products, range of techniques and tools are available in biotechnology. So biotechnology, we have to make use of fully and utilize or harness the technologies applications. So I urge the teachers as well as the students to explore more and more things and attend a conference like this, so you get more new informations. So even though you are sitting in a district headquarters, you have conducted this kind of nice conference from morning onwards. I am observing many resource persons are presenting very good ideas and concepts. So first of all, I congratulate and appreciate the organizers and the college, especially Madam Maria Sami. She contacted me many times and consulted me many issues around this conference, and she has been working tirelessly to get the successful output of this conference. And first of all, I would like to thank my friend Dr. Albert Prem Kumar to suggest my name for this valedictory function and evaluation of this conference presentations. So we have heaps and heaps of n number of applications, productions, products. All these things are around biotechnology. Biotechnology, as I told earlier, it is interdisciplinary and it is upcoming and modern subject. It is cutting edge of the subject. If we involve talented youth along with state-of-the-art technology and tools, we can get out of billions and billions of dollars of orders from outside India as well as inside India, and millions of employment generation also is possible. So with these few words, I congratulate the organizers once again, the college authorities and the presenting resource persons, and my dear beloved students, to patiently hearing my speech as well as the other resource person speech. So thank you so much. Thank you one and all. If you have any doubt or anything, you can ask me. Any kind of clarification, or I think it is one-way interaction, not two-way, I think. But anyway, you can put the questions in the box, so I can able to answer by today or tomorrow. Finally, I thank Madam Maria Sami and principal and other authorities in the college to organize such a good structured one-day conference. And really, I am enjoyed the resource persons and the presenters, especially the college teachers and the students. They did very nice presentations. And whatever the presentation, you just extend your research work further down and get out of some molecules or deliverables. Thank you so much. You please ask something if you want to get some clarification or doubt or whatever the things. Thank you so much.
Thank you, sir, for your inspiring speech. As we express our gratitude we must never forget that the highest appreciation is not to utter words, but to live by them. Now, I request Dr. S. Sivapriya, Assistant Professor, Department of Chemistry, to propose the vote of thanks.
Good evening, everyone. Thinking happy thoughts literally creates a positive chemical change in the brain, which stimulates both positive physical and physiological benefits. I am very elated to thank our Almighty God to give this successful day and to give this chance to me to thank. On behalf of our Immaculate family together and my own behalf, extend a very hereby vote of thanks to all the participants for sharing your finding and opinions today. Inspirations comes from within yourself. One has to be positive. When you are positive, good things happen. Our heartfelt thanks to our special guest, Dr. Albert Prem Kumar and Professor Sanyasi Elumalai for spending the valuable time with us from any corner of the world. Thank you, respected guest. Words are not enough to express my sincere gratitude to our Reverend Sister Sahayam, Secretary, Immaculate College for Women, who always stand by us, guide, motivate us to what we are today. Thank you, Sister. My heartfelt thanks to our principal, Dr. M. Sushila Devi, ICW, for her systematic planning, timely execution, periodically monitoring, and unfailing support us to make this conference in a successful manner. Thank you, ma'am. My sincere thanks to our Reverend Sister Maria Sami, HR, ICW, who has been the driving force behind this whole process. Her vision, interest, and hard work make this conference in successful way. Thank you, Sister. One opportunity used wisely can change a life dramatically. I wish my extend thanks to our research scholars, presenters from various universities and colleges for your hard work and also share your experience with us. Thank you all. I happily thank all our HOD, teaching and non-teaching faculties, technical team, and all the students to make these events in a successful manner. Once again, I express my thanks to all of you. Thank you.
Thank you, ma'am. The feelings when we hear our anthem will always rise our strength. Now, I request you all to rise for college anthem.
Immaculates, born to shine stars. We the Immaculates, born to shine stars. We the powerful women, we the great queens. We the powerful women, we the great queens.
We are strong in mind and heart.
We the Immaculates,
We are courageous women.
we the Immaculates, we the Immaculates, born to shine stars. We the Immaculates, born to shine stars.
Everything we do it with passion.
Everything we do it with passion. We will be more than women, more than women, more than enough for all. Oh yes, more than women. We the Immaculates, born to shine stars. We the Immaculates, born to shine stars. want it. We stand elbow knit. We dream it. We work hard. We grind till we want it. We the Immaculates. Born to shine stars.
The truth is our sound.
We the Immaculates.
They see us flying colors.
We the Immaculates.
We have a voice.
We have a mind.
We have a soul.
None can control.
Yes.
We have a voice. We have a mind. We have a soul. None can control.
Our motto.
Learn, light, and liberate.
Learn, light, and liberate.
We the Immaculates. Born to shine stars. We the Immaculates. Born to shine stars.